A cosmic giant is hiding its strangest secrets in plain sight. This is NGC 4889, a supergiant elliptical galaxy anchoring the distant Coma Cluster. It appears as a serene, fuzzy ball of ancient starlight, but that is a brilliant cosmic disguise. At its heart sleeps one of the largest black holes ever measured, a dormant monster with a mass of 21 billion suns. Around it, the galaxy churns with mysteries that defy our basic understanding of how the universe works. By the end of this exploration, you will know 25 of the most bizarre phenomena hidden within this galactic titan, from phantom jets to stellar graveyards and invisible megastructures. How can a galaxy be so massive yet so quiet? What unseen forces are truly in control there? The answers rewrite the rules of cosmic evolution. What do you think is the strangest thing a galaxy can do? Our first phenomenon reveals the galaxy's hidden temper. The central black hole in NGC 4889 is currently dormant, a slumbering giant not actively consuming large amounts of matter. Yet, surrounding its core, astronomers have detected the faint, ghostly echoes of a past fury. These are the remnants of a relativistic jet, a phantom beam of energy that once screamed across space. This jet is not made of light or gas as we normally think of it. It is a focused torrent of superheated plasma, subatomic particles accelerated to over 99% the speed of light, and launched from the poles of the black hole. The sheer power required to create such a structure is almost beyond comprehension, capable of reshaping entire regions of a galaxy. What makes this jet so strange is its behavior. It does not shine with a steady, constant brilliance. Instead, it flickers. Advanced radio telescopes have picked up its signature in patches, like finding the scattered, fading embers of a colossal fire that roared to life and then vanished. This intermittent signal suggests the black hole's feeding habits are wildly irregular. It might gulp down a star or a massive cloud of gas in a sudden, violent feast, powering the jet for a short cosmic moment, and then fall silent again for millennia. The phantom jet is a clue, a cosmic fingerprint left behind from an eruption we missed by millions of years. It tells us the quiet giant is not peaceful. It is merely resting, and its past outbursts have sculpted the invisible landscape of the galaxy around it. What could cause such a powerful engine to turn on and off so unpredictably? This phantom jet is not the only invisible force at work. Surrounding the entire galaxy is a second, far more profound mystery, an immense and nearly invisible megastructure. We cannot see it, touch it, or detect it with any telescope that observes light. Yet it is the single most massive component of NGC 4889. This is its dark matter halo. Think of the galaxy you see in images, that brilliant ball of stars spanning hundreds of thousands of light years, as merely the chandelier hanging in the center of a vast, empty cathedral. The dark matter halo is the cathedral itself, a gargantuan, invisible framework of unknown material that extends millions of light years beyond the galaxy's glowing edge. It contains perhaps 10 times more mass than all the stars, gas, and dust combined. How do we know it is there if we cannot see it? The answer lies in a cosmic illusion called gravitational lensing. The immense gravity of this dark matter halo acts like a lens in space, bending and distorting the light from galaxies that lie far behind it. Astronomers see these background galaxies not as neat spirals or ellipticals, but as stretched, smeared, and twisted into faint arcs of light, like reflections in a funhouse mirror. These arcs are the ghostly fingerprints of the invisible halo. The strangeness is profound. The visible galaxy, for all its grandeur, is just a passenger. It is this unseen dark matter structure that dictates how the stars move, how the galaxy rotates, and on a colossal scale, how the entire Coma Cluster of galaxies holds itself together without flying apart. The true shape and ruler of NGC 4889 is not made of stars, but of something we do not yet understand, a silent architecture holding up the cosmic stage. This invisible framework holds a secret at its very center, a light that should not exist. At the core of NGC 4889, astronomers have detected a persistent, ethereal glow in ultraviolet light. It is a soft, diffuse haze that blankets the galactic center, and it presents a profound puzzle. In most galaxies, a strong ultraviolet signal means one thing: a bustling nursery of newborn, hot, blue stars. But NGC 4889 is an ancient elliptical galaxy. Its star-forming days are billions of years in the past. So what is creating this ghostly ultraviolet light? The leading theory is as haunting as it is beautiful. This glow does not come from the birth of stars, but from their deaths. It is the accumulated radiance of a stellar graveyard. Picture the very center of this supergiant galaxy, a region of unimaginable density where stars are packed together millions of times more tightly than in our own neighborhood around the sun. Over the eons, the vast majority of stars there have lived out their lives and died. They have left behind their corpses, white dwarfs, the cooling embers of sun-like stars, neutron stars, the unimaginably dense cores of more massive stars, and stellar mass black holes. Each of these dead remnants still emits a faint trickle of energy, a final whisper of heat and light as they slowly cool or accrete minuscule amounts of material. Alone, one of these dead stars is incredibly dim, but together, in the crushing density of that core, the combined ultraviolet glow of billions upon billions of stellar corpses creates a detectable haze. It is a galaxy illuminated by its own cemetery. This phenomenon forces us to see the galactic core in a completely new way. The serene, golden light we see in optical telescopes is just the living population, the relatively few ancient red stars still shining. The ultraviolet view reveals the far more numerous dead, their collective faint light painting an eerie portrait of the galaxy's violent history. The core is not just a place of old stars, it is a cosmic charnel house, and its quiet glow is the sum total of countless final breaths. What does it mean for a place to be so defined by what has ended, rather than by what remains? The eerie glow of stellar ghosts is not the only legacy of the galaxy's violent core. From that same chaotic region come projectiles of a different kind, stars fired into the endless dark like bullets from a cosmic gun. These are hypervelocity stars, and they race away from NGC 4889 at speeds exceeding 2 million miles per hour. At that velocity, you could travel from the Earth to the Moon in under 8 minutes. The force required to launch a star, an object millions of times more massive than our entire planet, is almost unimaginable. The mechanism is a devastatingly precise cosmic slingshot, and it requires a pair of stars orbiting each other, a binary system, to wander too close to the dormant supermassive black hole. The black hole's immense gravity violently disrupts the binary's dance. In a flash of celestial mechanics, one star is captured into a tight orbit around the monster, while its companion is flung away at a staggering fraction of the speed of light. The captured star becomes a prisoner, doomed to circle the abyss, while the other gains its freedom in the most extreme way possible, ejected on a one-way trip out of the galaxy entirely. This star becomes an intergalactic traveler, a lonely beacon shooting through the void between galaxies. As it flees, it may leave behind a faint, temporary trail, a wake of disturbed interstellar material or a brief shockwave as it plows through the thin halo of gas surrounding NGC 4889. These runaway stars are more than just curiosities. They are direct evidence of the ferocious gravitational forces at play in the galactic core. Each one is a fossilized record of a single, catastrophic event that happened millions of years ago. A natural experiment demonstrating the raw power hidden within the galaxy's serene facade. Where will these stellar exiles end up? They are destined to wander the intergalactic wilderness forever, carrying with them the unique chemical signature of their home galaxy, a silent testament to the day they were violently born into the Great Dark. This galactic violence does not stop at ejecting stars. It also devours entire worlds. The serene giant you see is a cannibal. NGC 4889 is actively consuming its smaller satellite galaxies, a process that has been ongoing for billions of years and continues today. This is not a metaphor. We can see the evidence in the faint, ghostly smears of light that stretch for hundreds of thousands of light years around the galaxy's main body. These are tidal streams, rivers of stars being torn from dwarf galaxies that ventured too close. Imagine a small cluster of stars, a tiny galaxy in its own right, passing through the outer reaches of NGC 4889's immense dark matter halo. The difference in gravitational pull between the side of the dwarf galaxy closest to the giant and the side farthest away is so tremendous it creates a cosmic stretching force. This tidal force literally pulls the smaller galaxy apart. Stars are ripped from their orbits, not in a sudden explosion, but in a slow, inexorable unraveling. They are drawn out into long, faint ribbons that first wrap around the cannibal galaxy before eventually falling into its body, adding to its stellar population. Composite images that combine very deep exposures reveal these streams as ethereal veils, faint scars on the cosmic sky that trace the last moments of these galactic meals. The strangeness is in the timescale. We are watching a single frame of a movie that lasts for billions of years. The dwarf galaxy is not swallowed whole in an instant. It is disassembled over cosmic epochs, its stars gradually becoming indistinguishable from the trillions already in the giant. This process is the primary reason NGC 4889 is so enormous. It did not form all its stars in place. It grew to its supergiant status by feasting on its neighbors, absorbing their mass, their stars, and their history. Every time you look at its smooth, featureless glow, you are looking at the combined remains of countless smaller galaxies, all merged into one silent, golden giant. What does it mean for a galaxy's identity if it is built entirely from the pieces of others? These galactic feasts leave behind more than just stellar debris. They create colossal weather systems in the void. Deep within the galaxy's multimillion-degree halo of hot gas, astronomers have mapped something that defies expectation: vast, razor-sharp edges called cold fronts. Picture the atmosphere of a planet, where a wall of cold air might meet a mass of warm air, creating a distinct front that brings storms, now scaled that up to a galactic level. The halo surrounding NGC 4889 is not a uniform soup. It is a churning, superheated plasma, glowing intensely in X-rays. Yet within this inferno, there are clear boundaries where the temperature drops dramatically over a very short distance. On one side of this invisible line, the gas is at 10 million degrees. Just a short distance away, on the other side, it might be a relatively cool 2 million degrees. In the cosmos, that is a drastic and sudden change. The sharpness of these fronts is the real mystery. In such a turbulent, energetic environment, you would expect heat to diffuse quickly, smoothing out any temperature differences. It is like expecting to find a perfect cube of ice floating, untouched in the middle of a volcano's lava lake. How can these delicate structures survive? The leading theory points back to the galaxy's violent history of mergers. When a smaller galaxy is consumed, it does not just add stars, it also plunges its own reservoir of gas into the giant's hot halo. This can create immense waves or sloshing motions in the superheated plasma, similar to the way you might slosh water in a bathtub. These waves can travel outward for hundreds of thousands of light years, and as they propagate, they can sweep cooler, denser gas from the galaxy's inner regions out into the hot halo, creating these sharp, coherent boundaries. X-ray telescopes like Chandra capture these structures not as images of light, but as intricate maps of temperature and density. They appear as vast, subtle arcs and edges etched into the glow of the hot gas, ghostly imprints of ancient collisions. These cold fronts are therefore more than just cosmic weather. They are fossilized records of the galaxy's most violent meals. ripples still moving through its atmosphere billions of years after the impact. They show us that the aftermath of a merger is not a quiet event, but a disturbance that echoes for eons, shaping the very climate of the galactic system. The galaxy's violent history may have erased another type of cosmic structure entirely. For a supergiant of its stature, NGC 4889 possesses a surprisingly sparse collection of globular clusters. These are magnificent, dense balls of up to 1 million ancient stars each, orbiting a galaxy like a swarm of stellar bees. Our own Milky Way, a fraction of the size, has about 150 of them. A typical giant elliptical galaxy can have thousands, a glittering halo of fossilized star cities. Yet NGC 4889, one of the largest galaxies known, appears to have far fewer than its immense mass would predict. It is as if a vast empire has almost no castles guarding its borders. Where did they all go? The most compelling theories point directly to the galaxy's cannibalistic nature. During a major galactic merger, when two giant galaxies collide and combine, the process is not gentle. The immense tidal forces that stretch and tear dwarf galaxies are also perfectly capable of shredding the delicate gravitational bonds holding a globular cluster together. As a cluster is pulled through the chaotic merger environment, it can be stripped of its stars, which are then scattered into the general stellar halo of the giant galaxy. The cluster is effectively dissolved, its identity lost forever. Another, more dramatic fate is possible for those clusters that dare to wander too close to the center. The supermassive black hole's overwhelming gravity could disrupt a cluster on a close pass, either swallowing stars directly or flinging them out into the galaxy, again leading to the cluster's destruction. This creates a stark contrast with other famous elliptical galaxies. Messier 87, the giant at the heart of the Virgo cluster, is famous for its spectacular system of thousands of globular clusters, appearing like a cloud of golden dust around its core. The difference between these two giants suggests that NGC 4889's particular merger history was exceptionally violent and disruptive. A series of cosmic cataclysms that not only built its immense size, but also systematically demolished these ancient stellar nurseries. The missing clusters are not an absence, but a clue. Their scarcity is a silent testament to the ferocious turbulence that forged this galactic titan, a sign that its growth came at a terrible cost to the smaller, delicate structures that once called it home. The violence that erased globular clusters also preserved something far more fragile. Orbiting this galactic giant are some of the universe's most ethereal structures, ultra-diffuse galaxies, ghostly smudges of light so faint they were only discovered in the last decade. These are not small, dense dwarfs. Each one is as wide as our own Milky Way, spanning tens of thousands of light years. Yet they contain only about 1% of the Milky Way's stars. Imagine taking all the stars in our galaxy and spreading them out across the same vast volume, leaving unimaginable gulfs of empty space between each one. The result is a galaxy with the density of a cosmic cobweb, so transparent you could look right through it at the universe beyond. Deep sky images that penetrate the glow of NGC 4889 reveal these objects as the faintest possible smudges, whispers of starlight clinging to the edges of the frame. Their existence here is a profound puzzle. How can something so delicate survive in the gravitational turmoil surrounding a supergiant galaxy? Shouldn't the tidal forces that shred dwarf galaxies and dissolve globular clusters have torn these gossamer structures apart eons ago? The answer may lie in what we cannot see. Astronomers suspect these ultra-diffuse ghosts are absolutely filled with dark matter. Their invisible halos could be exceptionally massive and spread out, acting like a rigid, protective scaffold that holds the few visible stars in place against external gravitational pulls. It is a cosmic irony. The most visible galaxies are often dominated by dark matter we cannot see, while these, the faintest ghosts, might be the places where dark matter's grip is most obvious and essential for survival. They orbit the cannibal giant like spectral jellyfish, their delicate forms intact only because of an unseen, internal strength. What does the survival of such fragile things tell us about the true, hidden architecture of the universe? The ghostly galaxies orbiting this giant are not the only things that defy expectation. NGC 4889 presents us with a profound cosmic silence. For a galaxy with a supermassive black hole of such staggering proportions and a history of launching relativistic jets, it is eerily quiet in one critical part of the spectrum: radio waves. This is the radio silence enigma. Across the universe, the most dramatic and active galactic cores are often brilliant radio beacons. Their jets, powered by voracious black holes, accelerate particles that scream across interstellar space, emitting powerful radio signals that our telescopes can detect from billions of light years away. Think of galaxies like Centaurus or Messier 87, with their colossal, visible radio lobes stretching far beyond their optical light. These are the loud, shouting giants of the cosmos. By comparison, NGC 4889 is a whisper. Detailed radio sky surveys, which map the universe in these long wavelengths, show a conspicuous absence where this supergiant galaxy sits. There is no strong, persistent radio roar, only the faintest flicker from that ancient, fading jet. This quietness tells us something crucial about the black hole's current dinner plate. Powerful, continuous radio emission requires a constant, dense flow of matter spiraling into the black hole, a bustling accretion disk where magnetic fields are twisted into powerful dynamos that launch and sustain those jets. The radio silence suggests that flow has now slowed to a trickle. The black hole is in a state of extreme fasting. There is simply not enough material falling in to power a large-scale, ongoing radio engine. The environment around the black hole, its magnetic field structure, might also be unusually calm or disordered, unable to organize itself into the coherent beams needed for a loud radio signal. This makes the galaxy a fascinating hybrid, a relic of incredible past violence now existing in a state of profound quiescence. Its radio quietness is not a sign of weakness, but a clue to its current phase of life. It is a sleeping dragon, its fiery breath extinguished, leaving only the cold bones of its past ferocity to tell the tale. The profound quiet of the galaxy's core belies the chaos it has flung into the void. Drifting in the immense space between NGC 4889 and its neighboring galaxies are vast, faint clouds of gas with a startling chemical signature. They are rich in heavy elements, what astronomers call metals like iron, oxygen, and silicon. This is deeply anomalous. In the pristine depths of intergalactic space, you would expect to find only the primordial hydrogen and helium forged in the Big Bang. Finding clouds laced with the residue of stars is like discovering a modern, manufactured tool floating in the middle of an ancient, untouched wilderness. These metals are not born in emptiness. They are forged in the nuclear furnaces of stars and scattered across space by their violent deaths in supernova explosions. Their presence so far from any galaxy means they were forcefully ejected. These clouds are the cosmic equivalent of blast debris, fossils of past cataclysms on a galactic scale. The leading theory points to the galaxy's active past, when the central black hole was feasting and powering its colossal jets, or during periods of intense star formation triggered by galactic mergers. The energy released would have been unimaginable. This energy could drive colossal galactic winds, superheated streams of gas moving at thousands of miles per second, powerful enough to sweep up enriched material from within the galaxy and blow it clear out into intergalactic space. Alternatively, the mergers themselves could have violently stirred the galactic pot, flinging out great plumes of metal-rich gas through gravitational interactions. These clouds now hang in the darkness, cooling and dispersing over billions of years. They act as a permanent record, a chemical snapshot of the galaxy's most energetic eras. By studying their composition and location, astronomers can essentially perform an autopsy on events that concluded long before our solar system even formed. They tell us that NGC 4889 was not always a serene giant. It was once a cosmic powerhouse that polluted its entire neighborhood with the ashes of dead stars. What other secrets might be frozen into the chemistry of these ancient clouds? Those metal-rich clouds are a testament to the galaxy's explosive past, and that same violence may have left another invisible scar. Deep within the core of NGC 4889, the very fabric of space itself might be tangled. Observations hint at a magnetic field of extraordinary complexity, a twisted and chaotic web of force unlike anything found in a spiral galaxy like our own. In the Milky Way, our magnetic field is relatively well ordered, following the grand architecture of the spiral arms, a gentle guide for cosmic rays and star-forming gas. But in this ancient elliptical giant, the field appears to be a turbulent knot. Imagine the difference between a calm, flowing river and a whirlpool filled with churning debris. This magnetic maelstrom is likely a direct product of the galaxy's brutal merger history. Each time NGC 4889 consumed another galaxy, it did not just add stars, it also merged their magnetic fields. Think of taking two separate, intricate networks of threads and violently knotting them together over and over again. The result is not a neat new pattern, but a chaotic snarl. This twisted magnetic environment has profound consequences. Magnetic fields are the invisible tracks and accelerators for high-energy particles. The chaotic field in the core could act like a vast, natural particle collider, whipping protons and electrons to near-light speeds along its tangled lines. This process might explain the faint, flickering signatures of past activity, like that phantom jet, showing how even a dormant black hole can occasionally light up when stray matter gets caught in this magnetic maze. Astronomers study this by analyzing polarized light, a subtle property that reveals the alignment of magnetic fields. A map of this polarization around NGC 4889 would not show neat lines, but a swirling, confused fingerprint, the lasting imprint of cosmic collisions that happened billions of years ago. This hidden magnetic knot is more than a curiosity. It is the key to understanding how the galaxy's violent past still governs the invisible forces at its heart today. This chaotic magnetic knot is not the only lasting imprint of ancient violence. The stars themselves tell a story of repeated cataclysms, written in faint, concentric patterns that span the entire galaxy. If you could map the motion of every single star in NGC 4889, you would see something astonishing, not a smooth, random swarm, but a series of colossal, fossilized shock waves frozen in the stellar distribution. These are vast, faint shells and subtle ripples, like the circular waves spreading out in a pond long after a stone has been thrown in. Each one is a phase-wrapped fossil, the ghostly aftermath of a past galactic meal. The process is both beautiful and destructive. When a smaller satellite galaxy is consumed, it doesn't just vanish. Its stars are gradually stripped away and assimilated, but they don't instantly blend in. Instead, they are injected into new, distinct orbits around the giant's core. Over hundreds of millions of years, as these captured stars complete their long journeys, they begin to pile up at the turning points of their orbits, the farthest reaches of their elliptical paths through the galaxy. Picture a crowd of runners on a vast, oval track, all starting at different times. Eventually, you'll see more runners clustered at the far ends of the oval, where they slow down before turning back. This gravitational pile-up creates faint, shell-like overdensities of stars at specific distances from the galactic center. Because each merger event injects stars with a unique set of orbital energies, it creates its own distinct set of shells. The result is a layered archaeological record. The outermost, most diffuse shells are the fossils of the oldest, most complete mergers. while sharper, inner ripples might trace more recent or less destructive acquisitions. These structures are incredibly persistent, lasting for many billions of years because the gravitational environment in the galaxy's outer halo is so quiet. There's little to disrupt these delicate patterns. They are not structures you see in a typical telescope image. They are revealed through painstaking statistical analysis of star counts and velocities, a map of stellar traffic that reveals the history of consumption. These fossilized shock waves prove that the galaxy's serene appearance is a grand illusion. It is not a peaceful retirement home for ancient stars, but a dynamic graveyard where the echoes of countless collisions still reverberate, a silent testimony written in the slow dance of a trillion suns. How many lost galaxies are still whispering their names in these stellar tides? These fossilized shock waves are not the only stars that have been set adrift by the galaxy's violent past. A faint, pervasive light hangs in the space between the galaxies of the Coma Cluster itself, a ghostly luminescence that has no single source. This is the intracluster light, and NGC 4889 is one of its primary contributors. If you could see it with your naked eye, it would appear as an immense, incredibly dim fog, a sea of forgotten suns that fills the unimaginable voids between the cluster's brilliant islands. These are stars that have been completely liberated from their home galaxies. They are not in orbit around NGC 4889 or any of its neighbors. They are truly free-floating, citizens of the cluster itself rather than any single galactic nation. The process that creates this stellar fog is a direct extension of the cannibalism we have already witnessed. During the slow, gravitational dance of galaxies within the dense cluster, especially during close encounters and mergers, tidal forces do not just stretch satellite galaxies, they can completely pluck individual stars from their outer regions. Picture two galactic titans passing near each other, their gravitational fields acting like immense, invisible hands that reach into each other's stellar populations. Stars in the outermost, loosely bound halos are the most vulnerable. They can be gently, yet irrevocably, tugged from their orbits and flung into the intergalactic medium. Over billions of years and countless interactions, this process has released a staggering number of stars, perhaps as many as 1 trillion across the entire Coma Cluster. The strangeness of this phenomenon is profound. We are accustomed to stars belonging to a galaxy, anchored by its gravity. But here, billions upon billions of suns exist in the ultimate isolation, drifting in the deep, cold dark between galaxies. They are so far apart that the night sky from a planet orbiting one of these intergalactic stars would be almost completely black, with only the faint, smudged glow of distant galaxies to break the eternal emptiness. The intracluster light is the combined glow of these lonely wanderers, a testament to the relentless gravitational archaeology of the cluster. It proves that a galaxy's influence does not end at its visible edge. Its gravitational interactions pollute the entire cosmic environment with lost stars, creating a permanent, faint backdrop to the drama of galactic evolution. What would it be like to live on a world that belongs to no galaxy at all? The stellar fog surrounding this giant hints at an even more intimate drama unfolding at its very core. Deep within the dense swarm of stars at the heart of NGC 4889, astronomers are tracking a subtle, rhythmic anomaly. The motions of stars near the central supermassive black hole show a slight but persistent wobble, a deviation from the smooth, predictable orbits dictated by a single point of immense gravity. This wobble is the primary clue pointing to phenomenon 14, the potential existence of a binary supermassive black hole system. In simpler terms, there might not be one sleeping giant at the center, but two, locked in a slow, cosmic dance. The theory is a direct consequence of the galaxy's cannibalistic history. When NGC 4889 consumed another large galaxy, that galaxy would have brought its own central supermassive black hole to the merger. As the two galaxies combined, their central black holes would have sunk toward the new common center of mass, drawn together by gravity and the drag of surrounding stars and gas. They would then begin to orbit each other. What we may be witnessing now is the final stages of this process, a pair of black holes separated by perhaps only a few light years, circling one another in an orbital dance that takes thousands of years to complete. The evidence is in the details. As the smaller black hole moves through its orbit, its gravity tugs on the stars swirling around the primary black hole. Imagine a child spinning a heavy rock on a string, and then someone else gently tapping the string at a regular interval. The rock's path would develop a small, repeating wobble. Sophisticated computer models that simulate the stellar motions around a single black hole cannot fully reproduce the observed patterns, but models that include a second, smaller companion black hole fit the data remarkably well. There may also be hints in subtle, periodic flickers in the galaxy's core light, a potential sign of the smaller black hole occasionally snatching and tearing at a passing star or gas cloud as it swings through its orbit. This binary dance, however, is not a permanent state. It is a countdown to one of the most energetic events in the universe. As the two black holes orbit, they lose energy by stirring up the stars around them and, theoretically, by emitting ripples in spacetime called gravitational waves. This loss of energy causes their orbits to slowly shrink. Over millions of years, the dance will tighten. The black holes will spiral closer and closer together, until finally they merge in a cataclysmic collision that will release more energy than all the stars in the observable universe combined in that single instant, shaking the fabric of spacetime itself. The potential binary in NGC 4889 is a snapshot of this impending doom, a silent, slow-motion prelude to a cosmic detonation that will one day redefine its core. That impending merger is a future cataclysm, but the galaxy's present state holds a paradox of its own. NGC 4889 is the textbook example of a red and dead galaxy, a classification that sounds like a cosmic epitaph. Its vast population of ancient, cool, red stars gives it that distinctive golden hue. And for the most part, its epoch of furious star birth ended billions of years ago. Yet, this galactic giant is not quite as deceased as it appears. Deep within its seemingly quiescent body, astronomers have detected the faintest whispers of life, pockets of unexpectedly cold molecular gas, and the subtle, telltale signatures of very recent star formation. This is like finding a small, green sapling growing in the middle of a petrified forest. The presence of this cold gas is the key ingredient. For new stars to be born, you need dense, cool clouds of hydrogen and helium that can collapse under their own gravity. In a hot, violent environment like the halo of a giant elliptical, such gas should be heated to millions of degrees and dispersed, utterly incapable of forming stars. So where is this cold gas coming from, and how is it surviving? The leading theories point to two delicate processes. First, minor, ongoing accretion. The galaxy may still be sipping from the cosmic tap, slowly pulling in tiny filaments of pristine gas from the intergalactic medium or from the remnants of the dwarf galaxies it consumed long ago. This gas, falling in from the cold outer darkness, might manage to avoid being instantly superheated if it comes in along very specific, quiet pathways, pooling in sheltered regions. Second, internal dynamics could be at play. Vast, slow-moving waves of gas within the galaxy, perhaps stirred by those fossilized shells from past mergers, might cause pockets of the existing hot halo to cool and condense, much like a weather front forming a cloud. This sporadic, minimal star formation is not building spiral arms or lighting up the galaxy. It is a faint, flickering spark. We are likely talking about the birth of a few star clusters every few million years, a trickle compared to the torrential star-forming rates of spiral galaxies. But its existence is profoundly important. It tells us that the process of galactic death is not a simple on-off switch. Even a supergiant that has consumed its neighbors and exhausted its primary fuel can, under the right conditions, find a tiny reserve and create a few last new suns. It is a testament to the enduring, if subdued, dynamism of the universe. Even in the red and dead, the embers can occasionally flare. This faint, flickering star formation hints at deeper currents moving within the galaxy's ancient body, currents that betray a hidden asymmetry in its very heart. The motion of stars around the core of NGC 4889 reveals a startling truth. Their speed depends entirely on which way they are going. This is anisotropic stellar dispersion, a complex term for a simple, strange fact. The galaxy's core is not a smooth, round gravitational bowl. It is lopsided and dynamic. If you could take a velocity map of the stars swirling near the supermassive black hole, it would not show a uniform, blurry haze. Instead, you would see distinct lanes and patterns, like watching traffic on a city map where cars on north-south highways are consistently moving faster than those on east-west streets. In some directions, stars race around the core at blistering speeds, while in others, they follow more sedate, leisurely orbits. This anisotropy is a direct violation of what we might expect from a simple, serene elliptical galaxy. In a perfectly smooth, spherical gravitational field, stars should move with roughly the same average speed regardless of their orbital direction, like marbles rolling around in a perfectly round bowl. The fact that they do not tells us the gravitational landscape is being sculpted by something powerful and specific. The primary architect is almost certainly the supermassive black hole itself. Its overwhelming gravity dominates the innermost region, but it does not act alone. The potential presence of a second, smaller black hole in a binary dance, or the accumulated gravity of a dense cluster of stellar corpses and dark matter right at the center, can twist the gravitational field into a complex, asymmetric shape. Stars that orbit along the axis of this distortion experience a different effective pull than those orbiting across it, leading to the dramatic differences in their velocities. This anisotropic map is therefore more than a curiosity. It is a forensic tool. By carefully measuring these stellar speed zones, astronomers can reverse engineer the invisible mass distribution at the very heart of the galaxy. They are reading the subtle fingerprints of the central monster and its unseen companions in the paths of the stars it herds. The velocity map becomes an X-ray, revealing the broken bones and hidden structures within the galaxy's seemingly placid core, showing us that even the orbits of ancient suns are dictated by the hidden scars of past violence and the dark giants that linger there. What other asymmetries are written into the dance of a trillion stars? This lopsided gravitational dance points to the ultimate source of all this strangeness, the central actor itself, the ultramassive black hole. With a mass of 21 billion suns, it is not merely supermassive. It is a category of its own, an ultramassive titan. Yet today, it slumbers. The term dormant in astronomy has a very specific meaning. It describes a black hole that is accreting or pulling in very little matter from its surroundings. There is no bright, swirling disk of superheated gas screaming its final moments as it falls into the abyss. There is no brilliant beacon of a quasar, no roaring jet of plasma. The monster is fasting, and the galactic core is quiet. This presents a profound cosmic mystery. How does an engine of such unimaginable scale simply turn off? To understand the quiet present, we must reconstruct its violent past. Billions of years ago, during the epoch of galactic mergers that built NGC 4889, this black hole was almost certainly a blazing quasar. It would have been feasting on a torrent of gas and stars funneled in by the chaotic collisions, shining with the light of 1,000 galaxies, its energy output dwarfing everything else in the observable universe. It was the ultimate cosmic lighthouse. So what happened? The leading theory is one of catastrophic success. The black hole, in its most active phase, was so powerful that it essentially blew out its own fuel supply. Think of a fire so intense it creates a windstorm that scatters all the remaining wood. The energy from the quasar and its jets would have heated the surrounding gas to such extreme temperatures that it could no longer cool, condense, and fall inward. This process, called quenching, pushed the fuel reservoir away, starving the black hole and forcing it into dormancy. Another possibility is that the merger frenzy simply ended. The galaxy consumed all the nearby gas-rich satellites, and without fresh inflows of cold material, the black hole's dinner plate was eventually cleared. Its current quiet state, therefore, is not a sign of weakness, but a phase of exhaustion following an unimaginable feast. It sits at the center of its vast domain like a sleeping dragon atop a horde that has already been devoured, its kingdom now eerily still in the aftermath of its own apocalyptic hunger. That dormant state is the heart of a cosmic detective story known as the fueling puzzle. If the black hole truly has a mass of 21 billion suns, it required an almost unimaginable amount of fuel to grow that large. So where did all that gas go? The galaxy is not empty, it is surrounded by a vast, hot halo. But that halo is precisely the problem. It is too hot and diffuse to easily fall in. Solving this puzzle means reconstructing a crime scene billions of years old, and astronomers have several compelling theories. The first is simple: the black hole ate it all. During the galaxy's violent formative era, mergers would have funneled colossal rivers of cold gas directly toward the core, creating a feeding frenzy of epic proportions. The black hole may have gorged itself on this bounty with such efficiency that it literally cleaned out the galactic pantry, leaving only the scorched, diffuse remains we see today. A second, more dynamic theory involves powerful feedback. In this scenario, the black hole did not just quietly eat, it fought with its food. As matter spiraled in, the immense energy released by the accretion process, in the form of radiation and jets, acted like a cosmic hurricane. This energy blasted outward, heating and pushing the surrounding gas away, effectively shutting off the very supply line that was feeding the feast. It is a self-regulating cycle, a binge that triggers a purge, leaving the black hole starved in the aftermath of its own outburst. A third, more subtle possibility is that the fuel is still there, just hiding in plain sight. Some models suggest the gas might have settled into a large, stable, and incredibly inefficient accretion disk. Unlike the thin, hot, bright disks of active black holes, this would be a thick, donut-shaped structure where the gas orbits peacefully for long periods, only trickling inward at a glacial pace. Because it is not being violently compressed and heated, it does not radiate the brilliant light we associate with feeding black holes, making it virtually invisible to our telescopes. Each of these theories paints a different portrait of the galaxy's current phase. Studying this fueling puzzle in NGC 4889 is not just about one object. It is a masterclass in the life cycle of all supermassive black holes. It shows us that these monsters are not eternal engines. They go through distinct chapters, from violent, luminous infancy during galactic mergers, to a potentially long, quiet adulthood of fasting or slow digestion. The puzzle forces us to ask, is this dormancy a permanent retirement or merely an intermission? Could some future event, like a new galactic merger, reawaken the sleeping giant and restart the entire cycle? The sleeping giant at the galaxy's heart may be broadcasting its future on a channel we are only just learning to hear. This 18th phenomenon connects NGC 4889 to a cosmic hum felt across the entire universe, the gravitational wave background. If the galaxy's core indeed hosts a binary pair of supermassive black holes, their slow, tightening spiral is not just a local event. It is a direct contribution to this faint, all-pervasive ripple in the fabric of reality. Gravitational waves are not made of light or matter. They are literal distortions in spacetime itself, generated when massive objects accelerate. Think of the universe as a vast, still pond. When a single leaf falls, it creates tiny, barely noticeable ripples. But when two immense stones are swung around each other and then slammed together, they send out powerful, distinct waves that travel across the entire pond, subtly changing its surface. A binary black hole system with a combined mass of tens of billions of suns is the ultimate cosmic stone, and its final inspiral and merger would be one of the most powerful gravitational wave events possible. The signal from a single merger in a galaxy so distant would be a transient chirp in our detectors. But the universe is filled with millions of such giant galaxies, each with its own potential binary black holes at different stages of this slow dance. The combined effect of all these distant, overlapping chirps and rumbles from mergers past, present, and future creates a constant, low-frequency murmur, the gravitational wave background. It is a symphony of space-time vibrations composed entirely by colliding monsters. NGC 4889's potential binary is a key player in this orchestra. Even now, as the black holes circle each other over millennia, they are emitting these subtle ripples, slowly bleeding orbital energy and inching toward their cataclysmic union. Their contribution is a steady, low note in the universal hum. To actually listen for this specific note, however, requires a new kind of ear. Our current ground-based observatories like LIGO are tuned to hear the high-frequency waves from mergers of stellar mass black holes, collisions that last for fractions of a second. The dance of supermassive black holes is a million times slower, producing waves with periods of years or even decades, frequencies far too low for any Earth-based instrument to detect. This is where the future arrives. The Laser Interferometer Space Antenna, or LISA, is a planned European Space Agency mission that will launch in the next decade. It will consist of 3 spacecraft flying in a giant triangle millions of kilometers apart, trailing behind Earth in its orbit around the Sun. Free from the seismic noise of our planet, this space-based observatory will be exquisitely sensitive to those low-frequency gravitational waves. LISA microphone will be tuned to the bass notes of the cosmos. When it begins listening, one of its primary goals will be to map the gravitational wave background and pick out individual sources from the chorus. A binary system as massive as the one suspected in NGC 4889 would be a prime target. Its signal would be a slow, steady crescendo over years, a predictable waveform that LISA could potentially trace back to its source in the distant Coma Cluster. Detecting it would be a monumental confirmation, proving not only the existence of the binary, but also giving us a direct, dynamical measurement of its masses and orbit. It would transform the galaxy from a silent, golden image into a source of resonant vibration, allowing us to experience its core not with light, but with the very fabric of space and time. The galaxy's ultimate secret may not be seen but felt as a tremor in the cosmos. The gravitational hum of its core is mirrored by a delicate, colorful glow scattered throughout its outer reaches. These are planetary nebulae, the final, beautiful breaths of dying suns, and in NGC 4889, their population tells a strange and twisted story. When a star like our Sun reaches the end of its life, it does not go quietly. It puffs off its outer layers in a series of gentle pulses, creating a vast, expanding shell of gas. The hot, exposed core of the star then floods this shell with ultraviolet radiation, causing it to fluoresce in brilliant, ethereal colors. For a few tens of thousands of years, this glowing shroud, a planetary nebula, hangs in space like a cosmic ghost before fading into the darkness. In a typical galaxy, these objects are fairly evenly distributed, tracing the locations of intermediate mass stars in their final moments. But Hubble Space Telescope images of NGC 4889 reveal something different. The planetary nebulae here are not scattered randomly. They show peculiar clumps and voids, with some appearing in regions where there seem to be very few stars left to produce them. Even stranger, some of these nebulae are far too bright. Their intense glow suggests they contain unusual amounts of certain elements, like oxygen or neon, elements that are forged deep inside stars and only revealed during this violent end-of-life process. This anomalous population is a direct chemical fingerprint of the galaxy's savage past. The cannibalistic mergers that built this giant did not just add stars, they added entire generations of stars with different life histories and chemical recipes. A dwarf galaxy consumed billions of years ago would have had its own star formation epoch, creating stars with a specific chemical signature. When those stars finally die today, their planetary nebulae carry that foreign signature, appearing as unexpectedly bright or oddly composed objects compared to the nebulae from the galaxy's original stellar population. Their clumpy distribution maps the last visible traces of those devoured galaxies, like finding a cluster of distinctive, rare flowers growing in a forest, marking the spot where a foreign garden was long ago absorbed. These glowing shells are therefore more than just stellar tombstones. They are archaeological sites. Each one is a tiny, luminous capsule holding the chemical history of its parent star, and by extension, the galactic fragment that star once called home. By studying their light, astronomers can perform a cosmic autopsy, determining which nebulae belong to the original population of NGC 4889 and which are immigrants from its meals. The strange planetary nebulae are the last, fading voices of conquered galaxies, still singing their unique chemical songs from within the belly of the giant. The chemical songs of those dying stars point to a final, structural oddity at the very center of the galaxy itself. NGC 4889 lacks a bright central cusp, a missing piece of its architecture that speaks volumes. In many giant elliptical galaxies, the core is a searing beacon of concentrated starlight. The density of stars rises sharply as you look inward, creating a brilliant, steep peak in brightness right at the very center, like a towering mountain of suns. This is the expected signature of a galaxy that has evolved peacefully, its stars gradually sinking toward the middle over billions of years. But when astronomers map the light profile of NGC 4889, they find something different. That expected mountain peak is not there. Instead, the central region is more like a flattened hill, a plateau with a much shallower rise in starlight. The very heart of the galaxy has been hollowed out. This is not an absence of stars, but a relative deficit, a region where the stellar density is lower than it should be. The leading explanation for this cosmic excavation is as dramatic as it is precise. It is the work of a gravitational slingshot on a galactic scale. The scenario points directly back to the potential binary supermassive black hole. Billions of years ago, during a major merger, two giant black holes would have spiraled toward the common center of the new galaxy. As they danced ever closer in their final union, their combined gravity acted like a chaotic, immense thrashing machine. Stars that ventured too close to this binary pair did not get eaten instead. They were violently flung away. Imagine two giants swinging heavy weights on chains in a coordinated frenzy. Any smaller object that comes near gets batted clear across the room. This gravitational slingshot effect, over millions of years, would have systematically ejected thousands of stars from the innermost region, scouring out the core and leaving behind that characteristic shallow profile. The resulting structure is called a core galaxy, and it is considered a definitive fossil of a past merger between two massive galaxies, each with its own central black hole. The lack of a bright cusp in NGC 4889 is therefore not a flaw, but a forensic mark. It is the permanent scar left by the inspiral and merger of two ultramassive black holes, an event so powerful it permanently altered the gravitational landscape of the galactic center. The serene golden glow we see is not the original structure. It is the aftermath of a titanic collision that cleared the inner court, leaving a wide, quiet plaza around the now single, sleeping giant. What other invisible rearrangements did that ancient cataclysm cause? The hollowed-out core is not the only relic of ancient collisions. Drifting in its shadow is a stellar enigma, a dense, compact cluster of stars exhibiting a state of pure gravitational chaos. This is the high-velocity dispersion cluster, a knot of ancient suns where the very concept of orderly motion breaks down. Velocity dispersion is a measure of how much the individual stars within a group differ in their speed and direction. In a calm star cluster, like those orbiting our Milky Way, most stars move in similar ways, like a school of fish swimming together. The dispersion is low. But in this particular cluster near the core of NGC 4889, the dispersion is extraordinarily high. The stars are not swimming together. They are exploding outward in every direction simultaneously, a frozen snapshot of stellar pandemonium. The speeds are not just different, they are wildly so, with some stars racing at hundreds of kilometers per second relative to others in the same tight group. This level of internal violence is unsustainable for a normal, long-lived cluster. Left to itself, such a chaotic system would simply fly apart, its stars scattering into the galactic halo. The fact that it still exists, held together as a recognizable knot, means an immense external force is actively confining this stellar riot. There are two leading and equally dramatic explanations for its origin. The first is that this cluster is not a native-born structure at all, but the salvaged heart of a conquered galaxy. When NGC 4889 tore apart a mid-sized spiral or elliptical galaxy, the densest, most tightly bound part of that galaxy would have been its central nucleus, a region already packed with stars moving at high speeds due to its own gravity. As the outer layers of the victim galaxy were stripped away, this dense nucleus could have survived relatively intact, becoming a captive cluster orbiting within the giant. The high-velocity dispersion we see today could be the preserved fingerprint of that original, frenzied core. The second possibility is even more directly tied to the central black hole. This cluster may have formed or been captured in an orbit that brings it perilously close to the supermassive black hole's sphere of influence. Each time the cluster swings by on its elongated path, the black hole's gravity gives it a violent gravitational kick, a process called tidal shocking. Imagine shaking a bag of marbles vigorously. The marbles inside jostle and gain speed relative to each other. Over many close passes, these repeated shocks would pump energy into the cluster's internal motions, dramatically increasing the velocity dispersion of its stars, heating it up until it simmers in this state of chaotic motion. It is a cluster being stirred by a cosmic spoon. Studying this chaotic knot is like reading a pressure gauge. The extreme velocities of its stars tell us about the intensity of the gravitational forces it has endured, whether from a violent past as a galactic nucleus or from ongoing torment by the central black hole. It is a testament to the fact that in this galaxy, even the smallest structures bear the scars of the titanic powers that rule here. What does it take to turn a peaceful family of stars into a gravitational riot? That stellar riot is confined by a far larger, invisible ocean of fire. The galaxy is immersed in a sea of plasma, so hot it glows only in X-rays, a halo of multimillion-degree gas that extends for millions of light years. But this halo holds a critical clue. It is not a perfect, serene sphere. Chandra X-ray observatory images reveal a clear and startling distortion. The halo is elongated and asymmetrical, stretched in one direction like a cosmic comet tail. This is not a static structure. It is a shape born of motion and pressure. NGC 4889 is not floating motionless in the Coma Cluster. It is plunging through it at tremendous speed, perhaps over 2 million miles per hour. The space between galaxies in a dense cluster is not empty. It is filled with the thin, superheated intracluster medium, a diffuse soup of particles. As the galaxy moves, it rams into this material. The effect is like a giant ship plowing through water at high speed. The bow, the leading edge of the galaxy, experiences immense pressure, compressing and heating the gas in its own halo. Meanwhile, the trailing side experiences a relative vacuum, allowing the halo gas to stream outward, creating that elongated wake. The asymmetry we see is a direct snapshot of this dynamic pressure. a fossilized record of the galaxy's current trajectory through the cluster. It tells us which way the giant is moving and how violently it is interacting with its environment. But there is another layer. This distortion could also be a composite scar, a shape built up over billions of years from gravitational tugs during close encounters with other massive galaxies in the cluster. Each near miss would have pulled and stretched the hot gas, leaving a permanent warp in its structure. The X-ray halo's asymmetry is therefore both a present-day weather vane and an archaeological record. By mapping its exact contours, astronomers can not only plot the galaxy's current path, but also read the history of its relationships within the cluster's crowded metropolis. This invisible, lopsided cloak of fire proves that even something as vast and hot as a galactic atmosphere is constantly being reshaped by forces far greater than itself. What other journeys are written in the light we cannot see? That lopsided halo of fire is a testament to ongoing violence, but from that same chaos comes a whisper of creation. The debris from the galaxy's ancient collisions does not always scatter into nothingness. Sometimes it coalesces into something entirely new. This is phenomenon 23. The formation of tidal dwarf galaxies, a strange cosmic cycle where destruction gives birth to life. When NGC 4889 tears apart a smaller galaxy, the immense tidal forces do not just create faint stellar streams, they can also trigger the opposite process. As stars and vast clouds of gas are ripped from the victim, this material does not always disperse evenly. In the densest parts of those long tidal tails, the debris can begin to collapse under its own gravity. Picture a river of cosmic wreckage, millions of light years long. In certain eddies and pools along that river, the density of gas and stars becomes so high that it starts to pull itself together. These knots of material can become self-gravitating, forming a distinct, bound object, a brand new galaxy born from the ashes of an old one. These tidal dwarf galaxies are fundamentally different from primordial galaxies like our Milky Way. They are recycled. They are built almost entirely from the enriched, metal-rich debris of a previous generation of stars, meaning they start their lives with a rich chemical inheritance. They also often lack one crucial ingredient, dark matter. Because they form from the collisional debris of galactic disks, material that was already stripped of its dark matter halo during the tidal disruption, these newborn galaxies are made purely of baryonic matter, the normal stuff of stars and gas. This makes them unique cosmic laboratories, places where star formation and evolution proceed under entirely different rules. The question for NGC 4889 is, can we see this happening now? The evidence is subtle but compelling. While we are not witnessing a bright, obvious dwarf galaxy popping into existence in real time, the deep imaging that reveals the galaxy's complex system of tidal streams also shows distinct overdensities, brighter knots and clumps within those faint rivers of stars. Some of these knots have the right size, mass, and isolation to be candidate tidal dwarfs in their earliest stages. They are not yet fully independent galaxies, but they are the seeds, the potential future homes for new generations of stars. Their formation represents a profound irony. The same catastrophic merger events that fuel the growth of the central black hole and quench star formation in the giant elliptical can, in their outermost aftermath, create the perfect nurseries for new stellar life. It is a galactic ecosystem where death in the center funds birth in the distant outskirts. These nascent dwarfs, if they survive, will orbit the giant that created them, permanent satellites forged from the wreckage of their ancestors. They are living proof that in the cosmos, an ending is never just an ending. It is often the raw material for a new and unexpected beginning. What will these orphan children of destruction become in another billion years? Even the chemical echoes of creation hold secrets we cannot yet name. The interstellar medium of NGC 4889, the thin gas drifting between its ancient stars, emits a faint but distinct infrared signature that defies simple identification. When astronomers point powerful space telescopes like Spitzer or the James Webb Space Telescope toward this giant, they capture not just the smooth glow of starlight, but a series of sharp, narrow spikes and broad bumps in the infrared spectrum. These are spectral lines, the unique fingerprints of molecules and dust as they absorb and re-emit specific wavelengths of light. The problem is, many of these fingerprints do not match any known compound in our cosmic database. This is the enigma of unidentified infrared emission. The leading suspects are complex organic molecules known as polycyclic aromatic hydrocarbons, or PAHs. Picture these as tiny, flat flakes, molecular structures built from rings of carbon and hydrogen atoms, essentially microscopic soot. They are common in star-forming regions of spiral galaxies, where they are forged in the winds of dying stars. Their detection in a red and dead elliptical like NGC 4889 is surprising in itself, a ghostly residue of its last, faint episodes of star formation or a chemical legacy inherited from all the galaxies it consumed. These molecules would emit at very specific infrared wavelengths, creating some of the spiky features we see. Yet not all the observed emission fits the PAH profile. Some of the broader, more diffuse infrared glow could point to something even more exotic, like tiny nanodiamonds, specks of crystalline carbon formed in the shockwaves of ancient supernova, or other forms of carbon-based dust grains whose exact structure we have not yet replicated in labs. The challenge is immense. We are trying to identify the chemical makeup of specks of dust billions of light years away by the precise color of their faint infrared glow. It is like trying to determine the recipe of a cake by analyzing the shadow it casts from 1,000 miles away. What these mysterious lines reveal, regardless of their exact source, is that the chemistry within this ancient galaxy is far more complex and rich than we ever assumed. The interstellar medium is not a barren void of simple hydrogen. It is a graveyard of complex chemical wreckage, the accumulated ashes of countless stellar lives and deaths, now floating in the dark. Each unidentified line is a question written in light, a clue that the galaxy's history has seeded its emptiness with intricate molecular puzzles. What other complex chemistry is hiding in the quiet spaces between the stars? And what does it tell us about the building blocks available for any potential future life, even here in this seemingly dead realm? Those mysterious chemical lines are whispers from a realm where the laws of physics themselves begin to warp. This brings us to the final, 25th phenomenon, a consequence of pure, distilled gravity that borders on science fiction. At the very edge of the supermassive black hole in NGC 4889, time itself does not flow as it does for us. For a theoretical observer hovering near its event horizon, the point of no return, seconds would stretch into years from our distant perspective. This is the ultimate relativistic effect, a natural time machine operating in the depths of our cosmic backyard. The cause is not magic, but the profound curvature of spacetime described by Einstein's theory of general relativity. Gravity is not just a force that pulls, it is a distortion in the very fabric of reality. The stronger the gravity, the more severely spacetime is warped, and the slower time passes relative to a region with weaker gravity. At the surface of the Earth, this effect is minuscule, but near an object with the mass of 21 billion suns compressed into a point of infinite density, the distortion is so extreme it fundamentally alters the passage of time. Imagine two identical clocks, both perfectly synchronized. One remains with us far out in the galaxy's halo. The other is placed on a hypothetical, indestructible probe that descends toward the black hole's event horizon. As the probe gets closer, we would see its clock begin to tick slower and slower through our telescopes. The probe's signals would stretch out, its voice slowing to a deep drawl, its image reddening as the light waves are stretched to longer wavelengths. From the probe's own perspective, time would feel normal, but it would witness the entire external universe speed up in a frantic blur. If it could hover just outside the event horizon for what felt like a few minutes, it might see millennia pass in the galaxy outside, watching stars be born and die in fast forward. While we cannot directly observe this effect, no light escapes from that final descent. Its implications are mind-bending. NGC 4889 hosts one of the most extreme natural time dilation environments in the known universe. It is a place where the present, past, and future become relative concepts, dictated entirely by your position in a gravitational well. This phenomenon transforms the black hole from a mere monster of mass into a cosmic architect of time. It means that any event occurring near that horizon is, from our point of view, frozen in an eternal moment, a final frame of a film we will never see play out. The serene giant does not just hide the graves of stars and the wreckage of galaxies. It conceals a singularity where time itself grinds to a halt, a permanent monument to the most powerful force in the cosmos. What does it mean that such profound, reality-bending physics is not the stuff of distant speculation, but is actively at work, right now, in the heart of a galaxy we can point our telescopes at and see? From the frozen edge of a time-bending abyss to the faint chemical whispers between ancient stars, our journey through NGC 4889 reveals a truth far stranger than any serene portrait could suggest. This is not a simple, quiet giant. It is a dynamic, layered, and profoundly mysterious cosmic ecosystem, a place where the ghosts of devoured galaxies orbit in faint streams, where stellar corpses illuminate the core, and where a sleeping monster's past fury still sculpts the present. Every oddity, from the missing globular clusters to the chaotic stellar knots, from the phantom jet to the potential binary black hole, is a piece of a grander puzzle. Studying these 25 strange phenomena does more than satisfy our curiosity about one distant galaxy. It gives us a master key to understanding the violent, beautiful, and often counterintuitive processes that govern all galaxy evolution, from the frantic mergers of the early universe to the slow, quiet aging of the largest structures within it. NGC 4889 is a laboratory of cosmic extremes, showing us how black holes can both create and destroy, how destruction can birth new worlds, and how the universe writes its history not just in light, but in gravity, time, and invisible forces. So we turn the question to you. After this deep dive into the anomalies of a supergiant, which of these 25 phenomena fascinated or surprised you the most? Was it the hypervelocity stars fired like bullets from a cosmic gun, the idea of a galaxy illuminated by its own stellar graveyard, or the profound time dilation at the edge of its ultramassive black hole? Share your thoughts in the comments below. If you enjoyed unraveling these space mysteries with us, be sure to subscribe. There are countless more galactic enigmas waiting to be explored.